So once again, thank you all for joining for this first ever optional session of the CCNow Academy, or I guess it's the second one. Either way, we're so happy that you're here for us today because we're going to be discussing a very important topic, one that's very close to, I think, a lot of us, including myself, because I'm a meteorologist with covering climate now. And again, I know you all did introductions during that first introductory inaugural kickoff. But if it would be helpful, just go ahead and put your name, where you're coming from, and what you're most interested in covering or learning about tropical cyclones in the chat. I see Anya, sorry about the pronunciation if I got it wrong, from Sri Lanka, saying most interested in learning about how tropical cyclones, because they come from a tropical island that are very vulnerable for cyclones. Absolutely. So, as we continue to introduce ourselves, I want to introduce and I want you all to meet a very special guest that's joining us for this session. He's a fellow meteorologist and a close colleague, Shel Winkley. Over to you.
I don't know about special, but good to be with you here on this, what are we, Wednesday? My name's Shel Winkley. I'm the weather and climate engagement specialist as well as a meteorologist with the non-advocacy nonprofit Climate Central. So what we do is essentially we work on the data and the science of weather and climate change with the idea that we're going to communicate around it. So we really want to give that data to people like you who can story tell, right? You know where you live, the areas that you cover better than we do. So that's what we do. We develop and distribute compelling broadcast and publish ready climate content for you to help empower your forecasting, your storytelling, and the content that makes the crucial link between extreme weather events and human caused climate change, not only for you, for your education, so that you become a stronger reporter in and about climate change, but also for the people that you're talking to so that they can make the connections and then start to work on this problem together.
Thank you, Shel. And if you are not aware of Climate Central, I highly recommend heading over to their website. As my colleague Santiago says, there's a lot of great resources available. And we're actually going to be highlighting a few of them that are freely available for you all across the world later today. So, again, I think this is a very important session. I'm so glad that you're here today. In fact, I would even argue this is one of the more important sessions in our CCNow Academy series because I might be biased a little bit as a meteorologist, but again, tropical cyclones are some of the most devastating weather systems on Earth. Over the past half century, we have seen that close to 2,000 tropical cyclone disasters that have been attributed to them, which have killed almost 800,000 people and caused 1.4 trillion US dollars in economic losses. If you put that on a year to year basis, that's roughly 43 deaths each and every day attributed to tropical cyclones. Again, they're the most large weather systems on the planet and some of the most destructive as well. And unfortunately, research shows that these potentially deadly impacts from these storms are only going to worsen as our climate warms. So I know firsthand from covering hurricanes in the United States that these storms are not only incredibly powerful, but also hold a lot of emotional power as well. I mean, we give these storms names. We have names like Katrina, Maria, Haiyan, Daniel. All of these immediately remind us of the terrible devastation that these tropical cyclones can bring. So, with that, and since we have a small group, I want to open up to the floor. Feel free to raise your hand or unmute yourself and share your story. I want to hear from any of you to share a personal experience with a tropical cyclone. How have you been impacted or your community has been impacted and what did you see? I want to first, while you're all thinking about that, turn it over to Shel. Shel, what was when we talk about hurricanes in the US, what first comes to mind in terms of your personal experience?
I was a broadcast meteorologist before I joined Climate Central for 17 years, 15 of those in Southeast Texas. We're about 90 miles north of Houston, Texas. So we had to deal with the impacts of Hurricane Harvey. Um, we had 50 inches of rain fall in the 16 counties that we cover. Um, And I remember the first day that the forecast model started spitting out those totals. It was the same day as a partial solar eclipse was coming through Texas. So we had this big party that we got everybody together in the community to go watch it. And then I went back to work after that and I looked at the forecast and I was like, 50 inches. There's no way there's going to be that much rain. And then it just kept being consistent. And so yeah, that was a pretty rough 5 days that we had. The good news for where we cover is that we were basically the beginning of the rain. So everything that was falling on top of us was going downstream to the Houston area, who was also getting 50 inches of rain, plus everything that was coming down at them. But yeah, that's the most impactful hurricane that I've covered personally. Just the amount of water was I still can't believe like how much water and the places that we put that water, like how that all came together.
Thanks for sharing, Shell. Anyone else want to chime in about their personal experience or what they have seen when covering these tropical cyclones? I guess we can also do by just chiming in. Have any of you experienced tropical cyclones, whether it's a tropical cyclone or a hurricane or again, a cyclone? I see some people nodding no, and that's part of the good reason why you're here to kind of learn about these. We're going to have more time today to kind of discuss and share. Um, and the good news, once again, is this session is being recorded because we are going to be covering a lot and kind of come into a little bit of the science of it, which I think a lot of you are here for. If you have any questions, feel free to raise your hand. And if someone, Shell or Santiago, would just alert me if someone is raising their hand, I think I can see them. But if not, just feel free to remind me so we can go ahead and chime in. Okay, so let's talk a little bit about tropical cyclones. And I know my colleague Santiago has already put it in the chat that there's like different names. We're going to get to that in just a moment. But Bernard, I see your hand raised. I want to go over to you really quick.
Oh, okay. How are you all? Sorry, I missed the first session on the 17th. I was traveling. I'm based. Is everybody hearing me?
We hear you.
Are you here? Sorry?
We can hear you. Yep.
Yes. I said I missed the first session because I was traveling. However, I am a journalist based in South Africa. I did not really get that much experience of the cyclone in Zimbabwe, but I've got relatives who told me and whom I still communicate with, telling me the impact the of the cyclones that happened, I think, 2 3 years ago, and it's really devastating because those people have already been displaced by that. They lost their relatives there, and everything. There's a lot of things happening there, and I'm told the areas they've been relocated by the government. It's not really, there is no service delivery in that area. That is Zimbabwe. When I come back here, where I am staying in South Africa, I am a little bit far from KwaZulu Natal. A lot of things are happening, and I've been told, I've got friends there, I've been told there are a lot of things happening there. The communities, especially the vulnerable community, are not getting services from the time they were displaced. This is the little bit I wanted to share about it. So that's why you find I'm much interested to know how should I report on such issues. Because what I understand is a lot of has been said, but do we have personal experiences? People are telling their lived experience. Do we have voices of these people telling us how they are living now? Thank you.
Thank you for sharing. And you covered a lot of what we're going to be talking about because for a lot of folks, sometimes they think that these tropical cyclones, again, they form over oceans. So we think that it would only impact coastal areas. But we have seen time and time again here in the United States, in Africa, in Southeast Asia, they very much also impact further and further inland. And it causes real problems for years and years to come, as recovery can be very, very long. Okay, I want to continue on because I want to just go over a few quick things that would be really helpful for, especially for folks that don't know too much about tropical cyclones. And since we have a global audience here today, I want to briefly talk a little bit about some of the names that we call these storms, so there isn't any confusion amongst us, but also within your communities and the audiences that you speak to, in case you're covering a storm that's happening in the Atlantic or covering a storm that's happening in the Pacific and trying to make that link with climate change. This is, again, not only to clear up any confusion that you all might have, but also to ensure that you classify these storms in the correct way in your own coverage. So when in doubt, you can always use the term tropical cyclone. That's pretty much a catch-all when it comes to describing these massive rotating storm systems all over the world. In fact, meteorologists use this, and that's why we called this session covering tropical cyclones. But as we know, these systems are referred to by a variety of different names depending on where they form. You can see by this great graphic from NOAA here in the United States where you can see in the graphic hurricanes are in the North Atlantic and as well as the eastern and central North Pacific Oceans. So anything that's happening in the Caribbean, anything that's happening in the US, anything that's happening in Central America, that is going to be described as a hurricane. In fact, if you even go south of the equator in the South Atlantic, which is very rare to see tropical cyclones actually form there, they would also be called a hurricane. So on the other side of the world, cyclones cover the western South Pacific and Indian Oceans, while typhoons form in the western North Pacific around the Philippines, Japan, and China. Make sense? Again, different names, but no matter what we call them, fundamentally these systems are the same. They are massive rotating storms fueled by tropical water, warm tropical water. And we see that this warm water is the fuel for these storms. And unfortunately, we have a lot of it. Fatuma, I see your hand raised in the chat. Do you want to chime in really quick? Okay, we'll go ahead and move on. Again, if you have any questions, use that react button at the bottom of your Zoom screen to raise your hand. So once again, we know that every year has been warmer than the last. In fact, 2024 was officially the warmest year on record since record keeping began globally in 1880, breaking a record set only the year before in 2023. Globally, we've reached an average temperature of 1.5 degrees Celsius above pre-industrial levels. That marked the first time that world has temporarily crossed that critical threshold of 1.5 degrees Celsius that we have tried so hard to stay below. Now, consider just how much warmer we would be if it wasn't for the fact that nearly 90% of the Earth's excess heat is absorbed in our oceans. This, however, comes at a great cost. In fact, our oceans, our water is actually taking the brunt of this additional warming. It's kind of acting as a sacrifice for us because if it wasn't for our oceans, we would be so much warmer. But again, we're seeing this added warmth to our oceans, adding significant disruptions to marine ecosystems, acceleration of sea level rise, and of course, fueling record-breaking water temperatures that are fueling those stronger tropical systems. I want to take a quick look at a social media video of ours that offers a physical analogy to explore and explain how this extra warmth in the ocean supercharges hurricanes, typhoons, and cyclones by making a analogy to a raging fire that I think we all are familiar with.
As a meteorologist, I sometimes like to compare hurricanes to fires because mechanically, they're not too different. To start, they both need fuel. A fire needs some dry kindling, and a hurricane needs warm water, and a lot of it. When you get a match, or perhaps a cluster of storms coming off of Western Africa, you get ignition. Now, too much wind could snuff out our fire, and it's the same way with hurricanes. Strong winds high up in the atmosphere could rip apart fledgling storms. We meteorologists call this vertical wind shear. But most of the time, if there's fuel, there's a hurricane. And unfortunately, with our warming climate, there's a lot of fuel to burn. Scientists agree that our oceans absorb nearly 90% of excess heat caused by our greenhouse gas emissions. The extreme heat we're seeing in the Atlantic right now is like lighter fluid, driving stronger, more destructive hurricanes, which often strengthen right before landfall, placing more in harm's way.
So feel free to steal that. Again, I think it's a great analogy, and whenever possible, I like to talk about analogies when it comes to climate change because so many of these impacts and these climate connections are a little bit nebulous. They're a little bit hard to pin down because it's happening in our atmosphere, and we, again, don't have a physical manifestation of that. So that's why I recommend using things like fires and sponges, which we'll talk about a little bit later on. I want to bring in Shell here and just now to talk about this extra stored heat in our oceans and also highlight an incredible free resource for all of you to make that climate connection.
Yeah. So, again, with here at Climate Central, we're really into storytelling tools. What can you use to put in front of somebody that can really help tell the story? So when we do this, it's basically what's called attribution science. We're understanding how much more likely a temperature would be, in this case, sea surface temperatures, because of human-caused climate change, because of the heat-trapping pollution that we as humans have put into the atmosphere. So this is one of those attribution resources that you can make the link by quantifying the influence of climate change on those sea surface temperatures, showing how climate change has affected the likelihood of ocean temperatures across the world. So we can apply this science to every single basin that we have on this planet. And then we can, how it can turn a natural tropical cyclone into an unnatural one, a natural disaster into an unnatural disaster due to the boost in intensity because of climate change. So you'll notice here at the top, right under where it says Climate Shift Index Ocean, that is the tool's name. This scale goes anywhere from -1,000 to 1,000. And the value of 1,000 essentially means that climate change made the observed sea surface temperature in that part of the ocean on this particular day at least 1,000 times more likely due to climate change. So essentially what that's saying is that the heat that is being experienced, the unusual heat or the excessive heat, would be virtually impossible without the influence of human-caused climate change. And the reason that we can do this on such a big number is because it takes a lot to change the ocean's temperature, right? We also can do this science on land, but that scale only goes from -5 to 5 because land temperatures vary pretty quickly. You can get a weather system come through, a cold front, and that can change things very rapidly. The oceans, it's really hard to change on a quick basis. And you may have noticed some gray colors there. We'll talk about that, and we'll talk about what it takes to change things in our oceans. But I wanted to show you a live look of what the oceans look like today. So when you go in, and we can put this in the chat here in a second, but this is the Climate Shift Index Ocean. So again, you're looking everywhere across the globe, and you can see everywhere that there's red, that is where we, using the science, understand that climate change has influenced the temperatures. Sea surface temperatures anomalies, you can see the reds, that's where those temperatures are warmer than average. The blues are where they are cooler than average. So if we take a sample here in the Caribbean near Puerto Rico, we know that this temperature as of September 22nd, so this data usually is about 24 hours lagged, depending on when it comes in from NOAA here in the United States. It's using what's called OISST data. It's their data set for how they look at temperatures across our ocean basins. But we know that the temperatures there in Puerto Rico are as much as 300 times more likely due to climate change. We can go over here across the world and look near the Philippines. And I actually want to go back to September 20th, because if you've been keeping up, we had Super Typhoon Regasa that underwent that extreme rapid intensification, which we'll talk about more in a bit. But it came through these kind of waters that were warm. So as you know, the numbers aren't as big. We did an analysis recently where we found that this was anywhere from 10 to 40 times more likely for the waters that it encountered which doesn't sound like that big 1,000 number, but it's still significant because, again, the oceans are hard to change. So then we can track this along the way as it makes its move towards China as well as Hong Kong. Very quickly, I want to show you what else this tool can do. So let's go back to the Atlantic Ocean. And we'll come back to today, and then we'll click on the show tropical cyclones. Right now, we only have the Atlantic cyclones in, Atlantic hurricanes in. Hopefully by next season that will be changing. But you can track the path of what was tropical storm and then major hurricane Gabrielle. And we know that, again, once it came into these darker reds, so these are waters that are anywhere from 1 to 2 degrees Celsius warmer than they should be, even at this time of the year in peak hurricane season. But it went from a Category 1 storm to a Category 4 storm within 24 hours. It gained 65 miles per hour. We call that extreme rapid intensification. And that occurred over ocean temperatures that were much as anywhere from 50 to 100 times more likely because of climate change. And then it encountered waters that were up to 500 times more likely. So this is just a way to very rapidly understand what are these weather systems encountering? What is feeding them? And we know that ocean warmth drives the intensity of hurricanes. And this science can help us understand that in real time so we can give those to our viewers, to our readers, and help them make that climate connection in real time as well. One other link I'll drop in the chat, but we have ocean temperatures you can see at least since satellites began in the 1980s. This is every year of ocean temperatures worldwide. So right now we are the dark white line. The blue line is from 2024, which was our year of record. And we're still pretty close to those record temperatures that we set in 2024. You can do this for several different basins, but especially the world. So again, it's just a tool that you can use every day to help understand how much this ocean warmth is driving tropical cyclones. And David, one last thing, this tool works all year round. So if it's not a tropical cyclone, maybe it's a heat wave that you're experiencing in your city or your country. Especially places like the UK this summer, they had heat wave after heat wave after record heat wave. And what we found is that the waters around the country were also at heat wave level. And what we know is that land temperatures influence water temperatures, and water temperatures influence land temperatures. It's a feedback loop, and it causes more humidity the warmer our oceans are. So you can use this tool in several different ways to help quantify impacts. That way, and as David mentioned, ecosystems in our oceans, a lot of our communities depend on fishing and marine ecosystems. So this really helps tell those stories about what's happening in our oceans, because we're a water planet. Oceans are important, even if you're landlocked and you don't live near one. Oceans are more important than maybe what you think.
Absolutely. I mean, I think the possibilities for this tool, I think, are really endless. Again, even if you're not in an area that is affected by tropical cyclones, you can examine how it's impacting, again, fishing communities. I mean, some areas potentially are seeing record warm water temperatures that are made X amount more likely due to climate change, and you can make that connection. So again, this is a tool to bolster and help your storytelling and provide some of that science that your readers, your audience, will be able to quickly understand. Again, like we mentioned in our 3-pillar session, this is a great way to localize the climate story. It's not happening all the way out there in the Arctic. It's happening in our waters just off of our shores, and it's impacting extreme weather systems and ecosystems and the people and places that we care about.
Can I throw one more thing in, David?
Yeah, go ahead.
Just real quick. I just want to point out what Santiago put in the chat, which is, yeah, these are more likely. So a hurricane, I always say a hurricane's going to hurricane. A tropical cyclone is going to be a tropical cyclone, right? We're not saying climate change made these storms, but the waters that they're encountering, which are more likely to be this warm on any given day, we know that that's the ingredients to boost these storms, to make them stronger than what they might have been in more stable climate or a world without this excess carbon pollution. So a very good point there.
Absolutely. And again, to Santiago's point, we're going to be exploring this a whole lot more, because the difference between caused and influenced is a very important point to make, especially when it comes to climate reporting. In fact, this tool, as Shell said, uses a field of climate science called attribution, which dives exactly into this, which we have an entire dedicated session with later on for Academy participants. I highly suggest you all attend that session, not only because I'm leading it again, but also because it is incredibly fascinating. And I think it's a great tool for us journalists to make that climate connection and bring climate change home and make it presentable in a way that your readers and your audience understands. I just wanted to highlight it briefly because it can offer incredible insights to how climate change influences specific weather systems, such as these tropical cyclones. So, by way of example, let's actually take a look at a recent tropical system, Hurricane Erin, again in the Atlantic, but it was thankfully didn't really impact much land at all, but it was a very powerful storm. Back to you, Shaw.
Yeah. So what we know about Erin, the storm passed over waters that were excessively warm. We saw it kind of working through the main development region in the Atlantic for tropical systems. And we knew the spot that it was probably going to intensify, that it was going to grow into a bigger hurricane. And you can see on the screen there, this was a big weather system. And we knew that partially because, yes, some of the weather patterns were going to calm down, but also it was coming into waters that were excessively warm even for mid-August. So using this attribution science and doing the analysis with the climate shift index ocean, we show that that level of warming was up to 100 times more likely due to human caused climate change. So, and again, you notice how fast this went from a tropical storm to a category 5, another one of those storms that underwent this extreme rapid intensification, gaining categories of intensity and wind just within a very short amount of time. So then we can take that attribution science further and understand that the human influenced waters warming then in turn turned Erin's peak intensity up about 9 miles per hour, pushing it from what would have been a category 4 storm of 151 mile per hour to a category 5, the top of the scale, to a 160 mile per hour wind. It doesn't sound like a lot. 9 miles per hour, on a day when you're standing outside and you get a little breeze, that's not a lot. But what we do know is that even just 9 miles per hour can add as much as 25% more damage if this were to make landfall. Little changes in can lead to big impacts and influences out. So it's simply to say that if not for human caused climate change, Erin would have been a category 4 storm at its peak. But with climate change, we turned it into the top of the scale type of storm. And so I want to talk about that negative side as well. So if you look along Erin's track and move a little further to the north, we get these gray colors. So again, these are ocean temperatures that are now less likely in a warming world, meaning that we need something big in order to get that upwelling, bring up those cooler waters to cool down our ocean basin. And so it takes something like a major hurricane to cause that change of water. And what Erin effectively did in the wake of the storm is it caused temperatures to run 3-4 degrees Fahrenheit below average, which now and then in a world that we continue to warm due to this heat trapping pollution is up to 200 times less likely to occur because of climate change at the tail end of August. So again, doesn't mean that it's absolutely impossible, but we know that temperatures like this are becoming more rare. And it takes a big ticket storm like a major hurricane in order to change those ocean temperatures. So as journalists and your
Let me
community,
just jump in real quick,
okay,
Shell,
yeah.
Because again, to Santiago's point, I forgot to even include this. Again, we're going to be talking about a lot of numbers today, and I apologize if we don't bring up and make the conversion to kilometers per hour or meters per second or anything like that. Feel free to use that converter, but we're also going to be talking about the intensity scales. So when you hear about like a category 4 versus a 5 storm, and what does that mean in terms of what you might be familiar with a typhoon or a super typhoon, don't worry. We're going to get to that in just a moment. Just understand that these waters are rapidly intensifying, rapidly strengthening these storms and their storms winds.
Yeah, I was trying to do that math in my head and I wasn't going to happen.
It's hard.
So,
It's really
yeah.
hard.
Yeah. So, and then what we know about Erin too is that it was such a big storm, and no, it didn't directly influence land, but there was a lot of coastal erosion. There were houses that literally fell into the Atlantic even though the storm was well east of the United States East Coast. And so a couple different things there. One, the size of the storm. So again, the storm rapidly builds up in strength and then rapidly fell apart. So that allowed it to get a little bit bigger. But two, we know that sea level rise is part of this as well, because higher oceans, bigger waves, and then that can still impact people's homes and communities and the places that we love to go. So as journalists and your community's trusted messengers, this is just a powerful tool of highlighting climate change's fingerprint on extreme weather events that, threaten the places that I just said, that they love, that people love to go to, that people live in, that maybe is the only place they've ever known in their entire life. It makes climate change personal, immediate, and relevant to your viewers and readers. And it helps audience understand that climate change isn't just happening, like David said, in the Arctic. It's not just polar bears. It's not just this one area. It's happening to all of us. And we know that the way that people experience extreme weather is either what's happening out their door or what they're seeing on TV or what you're reporting on. So it really helps everybody understand the problems and the situation that we have right now in front of them.
Let's give Shell a round of applause for this, because again, it was super important data, super important resources as well. I encourage you all to sign up for Climate Central's newsletters and check out their website. Again, because there's more information and more resources for journalists and more information about that climate shift index tool that we have been showing off. With that, I know it was a lot of science thrown at you at the very beginning. Does anyone have any questions for myself or Shell when it comes to this? Feel free to raise your hand or just unmute yourself if you have any questions about what we just talked about. And if you need some more time to kind of digest, feel free to send us an email or reach out to Santiago, and he'll be able to put you in touch with us if you have any questions a little bit later on. Okay, let's continue on, because we have a lot to talk about and I think some really interesting stuff. But I want to open it up now with a little bit of something different, a quiz. So again, this is not like a test in like university or college or anything like that. We're not grading you. We're not judging you. It's just for us to kind of understand a little bit better about how we understand these tropical cyclones. So I want, if you all would be able to, open up that chat in the Zoom, and I want you to either select A, B, C, or D on which of these things you think is the correct answer. And here it is. So the question, what measurements or measurement do meteorologists specifically examine when classifying a tropical cyclone's strength and destructive power? Is it A, wind speed only? Is it B, atmospheric pressure? Or is it C, rainfall and flooding potential? So again, when we categorize and identify how strong a storm is, a tropical cyclone, what do we look at as meteorologists? Is it A, wind speed, B, atmospheric pressure, or C, rainfall? And again, take a guess here in the chat. Just put A, B, or C. We have someone chiming in B. Sorry if this is a very tough question. All right, we got a bit of a mix. We have B, we have C, we have B, C, A, someone saying all. I considered putting all of the above in there, but it's not there. Okay, so we have, I think, a good mix, and there is not a consensus yet, but that is perfect because we're going to be talking about this. The answer is actually A. Let's talk about this. It doesn't matter what basin you're in, whether it's the Pacific, whether the Atlantic, the Indian, the South Pacific. It doesn't matter where you are, and it doesn't matter if we're talking about hurricanes, tropical cyclones, or typhoons. When we look at and categorize these storms' intensities, we are looking at sustained winds. It's the one and only way that meteorological offices or weather offices across the world classify these storms' intensity. Now, that's not to say there's other ways for measuring these storms' destructive potential. Atmospheric pressure, absolutely, as well as rainfall, storm surge. But when we categorize these storms, calling it a tropical storm to a tropical depression to a hurricane, or a typhoon versus a very strong typhoon, or a violent typhoon, or a super typhoon, or a super cyclonic storm, it only is determined by wind speeds. And I will be honest, it is a little complicated because these are all of the different scales that these weather offices use all across the world when it comes into categorizing these storms. So, like, for example, here in the Atlantic, we use what's called the Saffir-Simpson scale. It's that category system that Shell and I were talking about earlier, going from a tropical depression to a tropical storm to a category 1, 2, 3, 4, and a very bad category 5 storm. In Australia, they also use a category system. It's a little bit different, and you can see they use knots and kilometers per hour. It's a little bit lower. For the West Pacific, for areas around Japan, they use, again, sustained winds, but they classify things with typhoons and even tropical storms. So again, let me just repeat this. When classifying a tropical cyclone's intensity, only wind is considered. The threat of deadly rain and storm surge does not factor into it, despite being the leading cause of fatalities from these storms. To put it bluntly, you can hide from wind and you can shelter from wind, but you can't hide from rising water. This is a huge topic of discussion in the weather community as more impact-based communication is highlighted instead of the focus on category and wind alone. I've seen this plenty of times in the United States where people don't take these storms seriously enough because they say, hey, it's just a tropical storm or just a tropical depression or only a category 1 storm or it's only a depression. So I'm curious, does this same sort of thing happen in your country or communities? So the question is, does your region's weather service do a good job in talking about the different types of impacts with these storms, whether it's wind, rain, and storm surge, or is there a lot of focus again on the wind? Based on your responses, I think there is a better, I would say, response compared to here in the US, because a lot of people are even saying atmospheric pressure as well as rainfall. So does anyone have anything to chime in when it comes to this? Or is anyone surprised by this scale compared to what we saw in the quiz? So again, when it comes to tropical systems, this is just something for us to be mindful of. The same thing with naming these systems. So put this in your back pocket. Be reminded of this whenever you're talking about tropical systems, that the scale that we talk about them is only determined by wind. But there's so many other different impacts that tropical systems have. And we're going to kind of go through some of these and explain what climate science tells us about how these storms and their impacts, namely wind, storm surge, and rain, are impacted by climate change and influenced by climate change. Again, don't worry about taking notes. Instead, I highly recommend checking out and bookmarking World Weather Attribution's reporting resource guide, which goes into not only this type of extreme weather event, but also many other extreme weather events like extreme heat and flooding and drought, and tells you specific language to use and what current climate science even tells about all of this. It's a great summary and it's available in over a dozen different languages. So check it out. I think one of my colleagues will be posting the link in the chat for you to explore this. And some of these things that we're going to be talking about in the next 20 minutes or so actually come from that resource guide. So let's talk a little bit about wind. We've already covered how warm water supercharges these storms, intensifying their destructive power with stronger and stronger winds. Often this intensification happens really quickly, rapidly, just like Aaron, like we saw, just like super typhoon that we're seeing right now, where they jump up in categories and jump up in intensity in just a mere matter of hours and maybe even less than a day. In fact, a study rather, posted to Nature found that nearly 80% of major hurricanes, that's again in the Atlantic, category 3 or higher, so those most powerful storms on Earth, now undergo this rapid intensification, become much stronger at some point within their life cycle. There is a problem. If this happens to happen right before landfall, when these storms move on land, it could be incredibly dangerous because this would provide less time for folks and people and communities to be prepared and to evacuate potentially. Shel, you want to briefly kind of talk about this rapid intensification because we have been highlighting it quite a bit?
Yeah, and I'll start with, what you just mentioned there is if it happens close to land, right? If a storm rapidly intensifies over the ocean, we can at least readjust and prepare for what is ahead. But if you remember from a couple of years ago, Acapulco, Mexico, was impacted by Hurricane Otto, I believe, and it was beyond what any forecast model had. It was supposed to be just a gentle, either tropical storm or Category 1. Ended up being a monster Category 5 hurricane and made landfall in a short amount of time, where people weren't able to prepare or get out of the city. And there was a lot of devastation. And it's those moments that we really need to pay attention to this. So we have two different things. One, what is called rapid intensification. And that's when it is, a storm that gains at least 35 miles per hour in 24 hours. But that's kind of natural. We've always had storms that have rapidly intensified, that have gone from one system to this greater system within a day. What we are seeing with climate change, though, is that what used to be maybe every couple of seasons that would happen, or maybe one a season that would happen, we're experiencing multiple of those. There have been 2 hurricanes in the Atlantic Basin this season, and both of them have undergone not just rapid intensification, but something I've mentioned a couple times, which is extreme rapid intensification. So this is a storm that's gaining 50 knots or 58 miles per hour in 24 hours or more of that wind, right? And so what we find with climate change is that this isn't something that was common or really even happened, say, a couple of decades ago, back in the 1980s, when we could really see everything that was going on because of satellites. But what you'll notice is that, at least in the Atlantic Basin, these bars are becoming more active once you get into the late 80s and early 90s. And then you start to see these bars grow bigger, meaning we're getting more storms that are undergoing this extreme rapid intensification multiple times a season. Again, we've already seen it twice with Aaron and now with Gabrielle in the Atlantic Basin. We just saw it happen with Regasa. They're near the Philippines. So what we know is that this is a phenomena that is happening more often now because of climate change. Again, this is something that we didn't used to have to forecast for or worry about. But now with our warmer oceans, because those oceans boost the intensity of hurricanes, we understand that this is something that is becoming more common in our warmer world.
I appreciate that. And especially when it comes to emergency preparedness, this is so critically important. So critically important. Again, we've been talking a lot about wind, and remember, wind is the big thing when it comes to how we classify these systems. But research shows that the majority of people that die in tropical cyclones, it's not from wind, but rather water. So let's talk about how climate change enhances tropical cyclones' rainfall and flooding potential. Just with all extreme rainfall events all over the world, whether it's a thunderstorm, whether it's a monsoon, whether it is just a tropical cyclone. I say just a tropical cyclone. A tropical cyclone. A warmer atmosphere means more moisture is available to fall as rain. Let's take a look at another example, another analogy, as explained by world weather attribution scientist Freddie Otto, as well as NBC here in the United States, climate reporter Chase Kane, talking about a hurricane last year that devastated the region that I live here in the United States.
Every hurricane that now exists contains more moisture than it would have without climate change. And that means the rainfall associated is in every case stronger than it would have been. And so the flood damage from hurricanes is larger because of climate change.
Freddie Otto researches how climate change influences weather. And with Helene, you can see the evidence with the amount of moisture it's holding, because warmer air can hold more moisture. Precipitable water, or PWAT, isn't something you hear us talk about on TV very often, but in the context of Helene and climate change, it's important. So here's what it is. Imagine you had a tube, a column of air that ran from the ground all the way up through the clouds, and it has a lot of water vapor, has a lot of moisture in it. Well, if you were able to squeeze all of that moisture out at once, precipitable water is a measure of how much rain you'd actually get down at the surface.
Okay, so if that didn't resonate with you, again, thinking about how our atmosphere holds more moisture, which can fall as rain the warmer it gets. It's not super complex, it's just physics, it's science. So another way to think about that is consider the atmosphere like a kitchen sponge that you use to clean dishes and all that, soaking up all that water. As we add more heat-trapping gases to our atmosphere, this sponge gets bigger and bigger and is able to hold even more water. So with these storms, some of that water is able to come out as rain. In fact, that storm that they were talking about just then, that you might have seen as it made headlines all across the world, Hurricane Helene, they found through attribution studies that climate change made its rainfall 10% heavier. And again, I know you might be thinking, and like we were saying earlier, with just a few miles per hour, it's only a small amount, 10% or a few kilometers per hour more. But when it comes to impacts, those small changes cause devastating impacts to communities. So again, there's rainfall, there is wind, and there's another impact from tropical cyclones that, I will be honest, it's a bit more complicated. And it's called storm surge. And this is the third main way that climate change enhances tropical cyclones' impact. It's actually indirect. So it's not impacting the overall strength of the storm directly like it is with wind as well as rain, but actually with the rising sea levels that are enhancing the storm surge from these storms. And you might be wondering, what exactly is storm surge? Storm surge is just a term that meteorologists use for that almost tsunami-like rise of water that accompanies these weather systems caused by both low pressure sucking up kind of a bubble of essentially ocean water and moving it on land, but also winds pushing that water on shore. So again, storm surge is complex, and it's actually influenced by a variety of different factors, which we don't have time to get into today, including a storm's intensity, how big and strong it is, how fast it actually is moving, how it approaches land and makes landfall, as even the shape of the coastline. So I don't have time to really talk about all of this, and it's very complicated, like I said. And it differs from storm to storm. There might be a storm that passes into your area that doesn't have a lot of storm surge with it. And there might be another one that potentially is even weaker that has a huge storm surge. We see this all the time in the US, and you likely have seen it in other tropical cyclone-prone areas. I would just recommend going to that site I just dropped in the chat, as they have a great breakdown of what storm surge is and how it's influenced, as well as that climate connection. But that climate connection, again, is rising sea levels allow for more of that water to move on land. So the three main ways that climate change influences a storm's intensity is, in those impacts, is it makes it stronger by warm ocean water. That same ocean water in a warmer atmosphere adds more water to it, adding more of that rainfall potential, and then potentially influences and enhances that storm surge. All right, let's take another quick question for you all. So go ahead and open up that chat and again put A or B. And this is a common question that I know I get, and Shell, I'm sure you get pretty often as well, about people asking about the link between climate change and tropical cyclones. Again, pick which answer you think is the most correct. Is it A, more tropical cyclones are forming as a result of climate change? Or is it B, the overall number of tropical cyclones per year hasn't really changed? So again, do you think we're seeing more tropical cyclones as a result of climate change? Or do you think we really haven't seen that much of a change? we have B, we have A. So far, a bit of a mix. Again, I apologize. We're throwing pretty hard questions at you today. I promise we're not judging, we're not grading or anything. We're all here to learn. I'm seeing more A's than B's, but still a decent little mix of B and A. All right, let's go ahead and see the answer. And I think Anya from Sri Lanka got it exactly correct. The answer is B. It's the overall number of tropical cyclones actually hasn't really changed globally, but climate change has increased the occurrence or those number of occurring most intense and destructive storms with those stronger winds, heavier rain, and potentially a larger storm surge. So exactly right. The overall number of tropical systems that we've seen so far hasn't changed with climate change, but what we're seeing is more of those stronger systems. And that's exactly so far what we are seeing this year. This is an active area of study. I encourage you to kind of look into it. And I understand I threw a lot of science at you all over the past 45 minutes or so. And there's plenty more that we didn't even get to, including how storms might be shifting further away from the equator, which is kind of known as a safe zone. If you notice, and it's actually really fascinating, these spinning tropical systems don't really cross over the equator. They stay in the northern hemisphere and the southern hemisphere, and then they really don't cross that divided line. It's very, very rare. But again, we're seeing potentially as that ocean warms, especially in areas further away from the equator, these tropical systems might be able to coast or move into areas that were previously thought safe from tropical cyclones as well as typhoons. This is an active area of research, especially in the North Pacific and in Australia. In fact, there's a very recent study that's really interesting that I'm putting in the chat right there. It's a little bit scientifically heavy, but it's still a very good piece of research. Does anyone have any other questions about what current climate science and research tells us about tropical cyclones? I guess the bottom line is that warm ocean waters, which we can show with those attribution tools that Shell told us about, are influencing these warmer tropical cyclones, again, which are not happening more often overall, but we are seeing more of those more intense tropical cyclones. And with it, we're seeing stronger winds, heavier rainfall, and greater storm surge. Any questions before we take a quick look at how others are covering these impacts in their communities? Okay, again, if you have any questions, raise your hand so we can answer them. As I mentioned at the very beginning of this hour, it's very easy to get lost in the science and the data when we talk about tropical cyclones. But I encourage you to always consider the human side of these storms. Remember, it's one of our three main pillars that we talk about: humanize, localize, offer solutions. And often the best way to show the human side of these storms is knowing that these tropical systems and covering these tropical systems is not just a weather story. The impacts of tropical cyclones are far-reaching and last long after those winds have died down and the floodwaters have receded, whether it's coastal erosion erasing communities, that tropical systems negatively impact public health, devastating agriculture, and even driving migration, as Bernard brought up at the very beginning of this session. There are so many different angles and story ideas to explore when talking about these tropical cyclones, especially for areas that are further inland. In fact, I would even argue that a lot of these impacts are felt most strongly in inland areas because they might not be used to this type of event and how to recover from that. We're seeing that firsthand where I live, in inland communities devastated by a tropical system last year, where they're still rebuilding. We're also seeing the recovery process being very long for other areas, whether it's in Africa, whether it's in Puerto Rico, whether it's in Southeast Asia. Again, the stories are numerous and they're all out there. And I encourage you not just to get into the science of these systems, but to find and tell the stories of the survivors and how people are recovering. There's so many different story impacts, whether it's infrastructure, public health, home insurance, agriculture, mental health, inequality, emergency alerts, and much more. So for this last bit of time together, this last 15 minutes or so, I want to take a look at how some newsrooms across the world have tackled this topic from some of these potential angles. And I encourage you to chime in and to follow along with some of these stories as I kind of highlight them. So this one, which I'm putting in the chat right here, feel free to click on it and follow along. This is a story coming to us from Yale 360. In fact, there was a number of stories talking about similar problems faced by these communities in southern Africa with this storm. This was Cyclone Freddy, especially for vulnerable communities, especially for mainly women who lost their land, their livestock, and their livelihoods. It's really a horrible story because this cyclone dropped 6 months of rainfall in just 6 days that triggered floods and mudslides that killed more than 1,200 people in this South African country. Again, this story, which I encourage you to really look into, shows that for some of these regions, the recovery process is incredibly, incredibly long. When we talk about the impacts of these storms and how it impacts agriculture and land and even soil, sometimes it takes years for the soil to recover. Because if we think about, especially in agriculture, the soil and the ground that we care about and grows crops, that's only really the top amount of soil. With these storms and the amount of rainfall, it essentially strips away that soil, leaving it barren, very hard for plants and even ground cover for grazing animals to recover. And that's only part of it. For some people whose entire livelihoods are based on agriculture, a storm like this could wipe away their entire crop and put them not only with food insecurity, but also economic insecurity. You can read more about this in this article, which I highly recommend. More than 2 million farmers in Malawi lost their crops as over 4,400,000 miles or acres of land were destroyed or washed away, and 1.4 million livestock were drowned, starved, or lost. This is an area, specifically Southern Africa, as well as Madagascar, that we really need to pay attention into the impacts of these tropical cyclones. And we can actually pinpoint some of that climate connection here. And I think there was attribution studies done with Cyclone Freddy, if I remember correctly. But again, think about the economic and the agricultural angle when it comes to some of these storms. I've seen some other examples about specifically in Southeast Asia about farmers actually changing the way they farm, essentially putting it in areas that they know are going to be flooding with these increased tropical systems because more systems just adding more and more rain and more flooding, they can't handle it. And once again, really explore it, find the human side of this story, and we're especially seeing it with this story in particular. Okay, when storms come through, they are violent, they are powerful. I mean, again, you're talking about winds upwards to 250, 270 kilometers per hour. That is allowing them to really tear up the land. I see your question. Cyclone Freddy lasted a record 38 days. How big of an anomaly is this? How long do those systems usually last? That is a great question. Shell, do you have anything to add to that? I know that Freddy was an exception to how long these tropical systems kind of last, but what we have also been seeing is these tropical systems can live for quite a while, especially if they form far away and they kind of coast along. You know, that storm you were talking about earlier, Harvey, it lasted for, I think, upwards to a week just offshore.
Yeah, and this is where the science is still trying to understand what's happening. But one of the trends that we're seeing with tropical cyclones and tropical systems is that once they move inland, they kind of just stick around for a long time. I would say 38 days is an I've never personally followed a storm that stuck around for more than a month. So I would say that is an exceptional scenario. But that is one of the active areas of research when it comes to climate change, is just the fact of slower moving tropical systems, sluggish tropical systems, and ones that just sit close to the coast that can continue to feed rain into the same area over and over.
Yeah, but as a general thing of like how long do the systems usually last, you can't really, I think, generalize because every system is different. You know, for some tropical systems in the Atlantic, they might last, 10, 12 days, while others might only last 5 or 6. And we're seeing that also in the Pacific. They have a lot more ocean to cover, and a lot more warm water. Let's talk about a different potential angle. And we brought this up earlier, with erosion. Again, those violent systems are able to tear up land, but also when it comes into just flooding areas with storm surge that never really recover. There's some great examples and some great sort of coverage that talks about this here in the US, also in the Southeast Asia. As you can see in this portion of India's southern region, where some areas are just unlivable. Their islands are shrinking as more of these violent systems continue to chip away at the land. And even if it isn't chipping away at the land, in some areas, with coastline loss as well as coastal intrusion, or that salt water moving further inland, we're seeing not only land loss, but also incredible amounts of erosion as well as mitigation as well. Let's move on because I want to open up the floor in just a moment. So definitely examine migration as well as that is in part caused by this tropical cyclone intensity, as well as some of this. And I apologize, it's northeastern India, not southern India. And then when it comes to public health, we understand that a lot of these tropical systems leave a lot of destruction in their wake, a lot of water as well. And what this can potentially do is cause public health emergencies. This story coming from the BBC, which I will put in the chat here, talks exactly about this, where in the aftermath of these storms, which can last for days and even weeks, they see an increase in infectious disease spread, whether it's cholera, whether it's Zika, West Nile, even Vibro, which is a disgusting bacterial infection, and a deadly bacterial infection at that. So all of this to say is that the impacts of these tropical systems and the coverage of these tropical systems should not end just as soon as the tropical system, the hurricane, the typhoon, the cyclone hits and it moves away. The impacts linger far longer, and they last, for some areas, days, weeks, months, and even years, as we're seeing here in the United States, where it's a long road to recovery. They're one of the most destructive, biggest storms that we have ever seen in the United States was Hurricane Katrina. It hit an area in the southern United States, in Louisiana, New Orleans, and now 20 years afterwards, just as of last month, they're still recovering. Even though a lot of things have been rebuilt, people and communities are still struggling to figure out some of those changes, and it comes into the inequalities. This fascinating study, this fascinating story from actually one of our award winners at Covering Climate Now examines this, especially looking at these Louisiana residents that are most vulnerable of deaths of despair, whether it's suicide, whether it's overdoses, whether it's just hopelessness and homelessness as well, 20 years after the fact. And we're seeing this also in other areas. Again, the bottom line with this is the recovery after these tropical systems is long. And this is why it's so important to highlight and cover these tropical systems with the human side of things and trying to make it as local as possible. The solution side of things, they're there. It's the infrastructure, it's the emergency alerts, it's letting people know how to better prepare and better handle the impacts of these storms that unfortunately are like a giant, again, they are one of the biggest weather systems in the world, if not the biggest weather system. They cover a huge amounts of the globe. And so we can't really stop them. So we have to understand, how can we best prepare for these systems as they continue to intensify, and how can we potentially stop some of that ocean from getting so warm? And it comes back to adding the ocean, or rather adding those heat trapping gases to our atmosphere. So yeah, health and climate, definitely look forward to covering that session a little bit later on. I hope all of you attend for that. We've covered a lot, and I want to personally thank Shell once again from Climate Central for joining us today and for talking about this, but also all of you for joining this optional session as well. I hope you found it interesting and enlightening. Feel free to reach out to me. My email is right there, david@coveringclimatenow, or Shell as well, if you have any additional questions about what we covered today or any other weather-related questions. Santiago, you want to call on someone? I saw your message in chat, but wasn't able to.
Yes, we have a colleague from Malawi here in the room, Gracious Molinga. I don't know if you're able to unmute yourselves, but I would love to hear from you how the media in Malawi did in covering Cyclone Freddy and the disaster that it caused. I can hear you barely. It's a bit low, but
You can hear me?
now I can hear you. Yes.
All right. We were hit by this cyclone. As you have said, Freddy, that was the most disastrous, I would say. But in the preceding year, we also had another one that was equally disastrous, but it was not as much as Freddy. But we, as the media, we covered the days before the cyclone, with the warning that the meteorologists were giving us. We were covering various programs, the news, and alerting people to ensure that they are ready when it comes to the day they are in spaces where they can be safe. And after the flood, even, we continued the coverage, especially considering that there were some rescue efforts going on to see some people were trapped in various places. So we kept the coverage. Even a year after, even this year, people are still writing stories about it, like the one that we have just seen. Was it from the one about after the storm, Malawi's farmers, blah, 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 blah. Yeah, those are the kind of issues that we are still looking at, because the impact of the cyclone can still be felt even now, about 2 years after the flood. And I would also say it also brought about some psychological trauma, so to say, to the people. Previously, people didn't trust the weather forecasting, but now when you talk about whatever is coming, people would be most likely will be there to listen to you because of what happened with the cyclone Freddy. So that's basically how it went down.
Thank you so much, Gracious. One thing that is very important that Gracious just mentioned is the mental health aspect that these disasters bring, and not only on the like on the general public, but also on us as journalists when we cover these stories. It's very likely that we're going to face really, really hard scenes and people affected by deep trauma. So I encourage you as well to take care of yourselves and take care of your mental health when you are following these kind of stories, because yeah, it can really affect all of us. We're also part of this, and we're also human. There's plenty of resources. I don't have any of them right now on my fingertips, so I apologize for that. But I'll try to include at least one of these resources on mental health for journalists in the follow-up email that you will receive in the following days. It's time, I think. I don't know if there's any more questions or comments. There's another question here. Do you have a relationship between climate change and culture? Well, that's a very interesting question, Bernard. I would say there's plenty, but I will give it back to David, who's leading this one.
Yeah, I mean, and this is part of, we've worked for an organization called Covering Climate Now, and we have literal coffee mugs that say climate changes everything. So I would argue climate change's fingerprint is on so many different things, including culture, because especially when it comes to tropical systems, how communities recover and how communities face, the aftermath of these systems is really influenced again by climate change. We saw this with music, we see this with media. I think you could argue that climate change is influencing culture. Again, you just have to sort of investigate arts and culture, especially as people try to come to terms with the changing environment and the changing extreme weather systems that they're seeing as well. Does anyone have any other questions? I know we're just past time, but wanted to leave the space open just for another minute or so for anyone to chime in.
I'll just throw out one more thing. What we always say is that conversation and communication is a solution to climate change. A lot of times when people ask us, what can I do as one person? Just having a conversation like we're doing today is a start of a solution. So really, that's just a thank you for what you do and the reporting that you do and the storytelling that you do, because it really is so important.
I think that's a great way to wrap things up. For those of you that are in areas impacted by tropical systems, I truly hope that it is a quiet season, a quiet year for you all, that we don't see any big storms impact, and we can kind of breathe a sigh of relief because we've seen the impacts of these systems and how much it can cause problems. So with that, I want to thank you all again for attending this next optional session. I forget exactly what's coming up next, but you'll see emails, I think, coming from Santiago. What's
Climate science, actually, I think.
Oh. So if anyone wants to learn more about climate science and has any questions about myths or some of those common misconceptions or disinformation, attend for that and you'll see me then. Otherwise, I hope everyone has a great rest of your day, a great rest of your week. And if you need anything from us here at Covering Climate Now, feel free to reach out.
Thank you so much, everyone. Climate science next week. I didn't make that one mandatory because, yeah, I didn't want to make it so many mandatory sessions, but it could be. It's really, really that important. And David here again is leading it, so you already see how good he is as well. So hopefully I'll see you next week along David.